Okay, let me see. Okay, so today I wanted to review about the blog post from Tezos Ukraine about Deku change. This is the first Tezos sidechains on Jakarta.net. So what is Deku? What is sidechains? And how is it working? So we see here saying that Marigold has announced the Deku sidechains as a layer 2 solution for Tezos, and it has been deployed at an alphanet version on the Jakarta. So here in this web page, there is a stream interview with the Marigold developers. You can also go there and listen to the whole conversations. So this blog post is the summarize of that discussions. And so why does it need a side change? Good questions. We have a blockchain, and why do we need another layer 2 or another change? At the characteristic of a blockchain is that we have the security, we have the decentralizations, and the throughput, and also the number of transactions that we can perform in a blockchain. And so this has a lot of limit because the Tezos blocks is depending on the timing of the blocks. So about 15 seconds they rated the one blocks, if I remember well. Then they have depending on the these full blocks, like the number of transactions per second is not a lot. So to improve it, then that's why they need a different solutions to increase the numbers of transactions and the speed of how these transactions was validated. And so there is many solutions. So sidechain is one of the solutions that is currently present in the Tezos blockchain. So others solution is Toru. There's a link. It means the transaction optimistic runoff, and Scorus is the smart contract optimistic runoffs. Those don't make Tezos much faster, but it will at input speed of the runoff will tie to the speed of the Tezos blockchain. So sidechains is another story. Sidechain is able to increase the speed and the number of transactions per second, because it's also, I'm going to talk about it later. And what you can do with the side change is a blockchain bridge to maintain and enabling user to move the asset between both directions. So it means that you can communicate with Tezos, and you can transfer the token or anything on it between the two chains. There is that if you're using sidechain, it's gonna lose the decentralized centralizations, but it will improve the number of transactions and paying low fee that don't require maximum security provided by everyone. So there is many reasons for using sidechains, even if we know that we're gonna lose the decentralization in different applications, that you don't need to require a lot of decentralization. For instance, you're getting games or some private blockchain, or for your business or something that you said, oh, I don't really need the decentralizations, I wanted to apply on this change, and I wanted to use the benefit later to communicate with the blockchain and the main change. So that the ideas. So Deku is a manga. It's the characters in a manga named My Hero Academia. And so Is this a full blockchain? This is imagine that you have Tezos, and then this is one is not a clone of Tezos, doesn't have any common code on Tezos, and it's completely fresh, new, written full blockchain with the node that provide that you can produce the nodes and can validate the node that is completely independent with the Tezos. And but inside, to be able to communicate with Tezos inside Deku, they embed the live Tezos client in it for its consensus in the Tezos smart contract. So you can go and inside Deku, you can use Tezos client to call, doing transaction, to orientate your smart contract, and so on and so forth. And so it's update this contract with the state of its consensus. It's allowed that the two user move asset between two chains, provide an extra layer of security for Deku consensus. So as I said, it is a full blockchain. It has a node. It's able to produce, to validate blocks. It also have its own consensus, and currently it's using the proof of authority, but it also can change. You can use whatever the consensus that you want on Deku side. And what is proof of authority? It means that the node owners have to accept the new validators in the network manually. So imagine that you have a node and you wanted to edit a new validator. You say, hey, I know that person, and so I add them by manually like this, and not via any like proof of stake that you have enough of stake or something like that. And so right now Marigold is maintain those nodes. And so what is inside the vote contract that the bridge on the Tezos, the Deku node, the Deku vote contract on Tezos store. So all these informations that is the root hash of the Deku state, the current validators, and the ticket that deposited by the user. So on the Tezos side, this contract Deku will see, like Tezos will see, like there's a change, and inside there's a smart contract running on it, and then I see from this smart contract, it's like a bank. Imagine a bank, and then the Deku is like a bank, and Tezos is his partner or something, and say, from you, I don't need to know what are you going to do inside your management and everything, but I just need to know what is your state, and who is running it, who is the validators, who is the boss, and the numbers of the ticket that the user have been deposited to you. So that's all I need to know. And so currently the benchmark for the Deku is around 5,000 transactions, and it's the team announced that it's confident to reach 20,000 transactions per second, and they target 50,000 transactions by the end of the year. So that improved a lot of the how do they like because the nodes now to see that the depend on the hardware that you're running the node. It's the really powerful hardware, powerful piece of machine that running this is gonna improve a lot of the powers of power speed and the computations that making the transactions that improve much higher than the others on the side. So Deku have the Deku P and Deku C. Deku C stand for the canonical. This is the one that running on alphanet right now. It support the swap WebAssembly smart contract and interoperate with the ticket. And Deku P is stand for the Deku parametrics. It's a framework that creating a private blockchain. So unlike other solution to rate in a private blockchains, while you're using the Deku P, you only need to develop the state machine to process the transactions. So you just need to focus on how your blockchain application runs, and Deku will take care of the consensus on the transaction, how you want it to be validated, or who's gonna validate it, and it provide you the ticket. You just need to focus on the application. Everything under the blockchain, the DQP is gonna take care of it. What you can do with Deku in current state. So there are 3 entry points in the Deku contract. So remember, at the Tezos, you see the state of the Deku. It's like so who gonna do that is the validators in the Deku side. Is gonna in charge of updating the state hash, or whatever is the state of the that Tezos need to note. And on the user's point of view, that you're able to deposit it, and you also withdraw. And what is running in Deku is the ticket. It's ticket mass contract, and on the other side is gonna see that ticket, and it's using this ticket to withdraw and to deposit. So the deposit work like regular rich. So imagine right now you are the user, you go to the bank into Deku, and you say, hi, I have this number of ticket on, and then I wanted to deposit into your bank. And so the Deku node kind of watch. It's like you have a people working at the table and say, okay, I gonna check your ticket. I gonna check how many tickets that you're gonna deposit into the address inside Deku. You need to deposit there. They register for you the account into the Deku address with the number of tickets that you deposit in, and then they're gonna freeze your ticket at the deposit. So this is really important, to freeze the tickets, because you're gonna need that to prove when you want to withdraw that. So see, you must provide a contract on layer 1 proof that the ticket will burn on Deku. So when you withdraw, Deku is gonna burn the free ticket, and that is provide you. I say, hey, I already have a proof that you from the beginning you deposited, I burn it, and this is the proof. You take this proof to the Tezos side and say to the Tezos side, hey, I have the proof, and can I withdraw it? And then the Tezos side gotta check, and if it's correct, then you gonna withdraw the number of tickets that you have, and you already do whatever you needed to do in the Deku side. So now you good to go. And so user can deploy contract program using the Swarm virtual machine on Deku, which they can call using transactions. And they will have only implemented Swarm because it's easier than porting migrations. An external user can deploy their Deku network using Swarm or other virtual machine. Allow sidechain that go beyond the current blockchain primitive execute any code. Technically, migration could also be implemented, so Tezos team can scale their products on layer 2. So you're able to use virtual machine to run the smart contract, or you can do directly the migration smart contract that implemented on this layer 2, and then see the scale for it. Why ticket? It's a standards that using right now, using between layer 1, layer 2 to do the communications. And Deku is one of these applications that promote a ticket, because right now on Tezos there's no application or no one using the ticket. And also Marigold has another project that improves the user experience, that graphic interface, so you can wrap your Tezos token into the ticket and then transfer them to Deku to other layer 2 solutions. So that's it